Hello, this is Algebra 1, topic 6-5, over graphs and functions. So, let's go ahead and start with a word problem. A shoe store is having a sale. The first pair of shoes sells for $40. So the number of pairs would be 1, and it costs $40. The second pair sells for half price, or $20. So 2 pairs. Now this is total cost. So this would be 40 plus 20 equals 60. The next pair sells for half of that, and so on. So 3 pairs would be 40 plus 20 plus 10 is 70. So the fourth pair would be 40 plus 20 plus 10 plus 5 makes 75. And the fifth pair would be 40 plus 20 plus 10 plus 5 plus 2.5 is 77.5. Started to run out of room there. And so here we have a relationship, and this is actually a functional relationship because we have an input value, that's our how many pair of shoes we buy, and we have an output value, that's the total cost. Well, now let's go ahead and figure out, well, which one of these depends on the other. Well, it's quite simple. The total cost depends on the number of pairs. Now, we talk about this because we have an independent variable and a dependent variable. The independent variable, that's the variable that either doesn't care or we choose. Well, here we choose how many pair of shoes to buy. And then the cashier tells us how much it costs. So our independent variable would be the number of pairs. Whereas the dependent variable is the total cost. Because we go up to the cashier and say, I want to buy 4 pair of shoes, and he does the formula and says, well, that'll be $75. Now, we say this, and we're going to write this sentence. We're going to say that the total cost is a function of the number of pairs. And now we have our ordered pairs of 140, 2, 60, 3, 70, 4, 75, and 5, 77.5. And now we need to graph. So I need to look at my graph and see what I'm doing. Well, this is going to be 0, 0. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. I've only got to introduce 5, so I'm going to skip lines. 1, 2, 3, 4, and 5. Now over here, I've got to get to 77.5, which means I really need to get to about 80. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I could count by 10s. That would put me to 100. Maybe I could count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Not going to work. So I'm going to have to count by 10s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And I chose this because I know that I'm going to fit everything here. Well, this is my number of pairs because independent always goes on bottom. This is your X, and the dependent is your Y. It goes on the side, and this will be total cost. And now I simply mark it. Well, if I buy 1 pair of shoes, that's going to cost me $40. 2 pair will cost me 60. 3 pair will cost me 70. 4 pair will cost me 75. And 5 pair cost me almost 80. And I'm just going to leave this like this. Do not connect the points. Now the reason is because I can't buy 1.5 shoes. Okay? I can't buy 1.5 pair of shoes. Alright? And so this is discrete data. Because there are obvious gaps in my thing, I can only do certain points, and so that means it is discrete. Let's go ahead and move on. Now we're talking about example number 2. We have a balloon being inflated with air. As more air is pumped into the balloon, the volume increases until it finally bursts, and we want to sketch a graph that represents the situation. Alright? Well, before we even sketch on the graph, let's determine which one is independent and which one is dependent. So which one do we have control over? Do we have control over how much air is pumped into the balloon or the volume? Well, we can't control the volume directly. We control the air pumped in, and we get the volume. So that means that the volume is a function of air pumped in. So now we label this air pumped in, and over here we put volume. And they didn't give us any numbers. And so we're just going to guess, well, no air means no volume. And then as I pump air into it, it gets bigger until finally it bursts. And I'm left with 0. Okay? And so as I pump air in, I get bigger and bigger and bigger, and all of a sudden I've got a big open circle here, because at this moment in time it is no longer full, it is now at 0. And this is continuous data. Even though I have a gap here, because I can be everywhere in between, that is continuous. Alright, so that was a real-world example. They didn't give us numbers, we just needed to give a graph. And now let's see if we can pick the graph based off of a story. And so this says, for a certain time, Lucy jogs up a hill at a steady speed. She runs down and then picks up her speed. Which graph below accurately represents the situation? So, she jogs up at a steady speed. Then she jogs down and picks up speed. Notice we're talking about speed and time. We are not talking about height. So I don't care about the hill or that I'm going down the hill. All I care is that I'm going at a steady speed, and then I pick up my speed. Well, here I'm going steady, and then I speed up. Well, it looks like that's what I'm supposed to do. Well, let's check over here. Here, I speed up, and then I slow down. And over here, I speed up, and then I go steady. That's not it. So graph 1 is the graph that we wanted because we don't care about the elevation. What we care about is her speed. That's why it's not graph 2. Let's go ahead and take a look at our next example. Here we're given a table and we're trying to figure out what this is. So I've got graphs 1, 2, 3, and 4 at the bottom of the page. 1, 2, 3, and 4, and I want to identify which of these 4 matches example A. So height of a falling object, as this goes up, it looks like that this is going down. So as we go higher, we go down. This is X and Y. X, Y, and so that would be this one, because as time goes on, we go down. So this would be graph number 2. And we would say that height depends on time. You drop an object and then you measure how much time happens, and gravity, which is something that you don't have control over, determines how high it is. Let's go ahead and look at B, the cost of postage stamps. Well, let's skip the graph for right now, but the year and the cost. Well, if you've got a time machine and you pick a year and then you try to go buy a stamp, the post office will tell you how much that stamp costs. So we're choosing what the year is, and the post office chooses what the cost is. So that means that this is X and this is Y, and that cost depends on the year. Well, as time goes on, cost goes up. And if we'll notice, it stayed 22 cents all the way up until 1985. And then it stayed the same all the way to 89. And then it stayed the same to 93. And then 95, it stayed the same again. And so we're actually looking for a bunch of flat spots that jump up. And that's what graph 3 gives us. So, this was about understanding how graphs work in the real world and how functions can be graphed. Good luck on your assignment. Have a good day.